So today we are reviewing exponents. So follow along on your guided notes as we work through these examples. So for number 1, we have x to the power of 3 times x to the power of 5. So when we're multiplying numbers with exponents, we actually want to add these exponents together. So we're going to add up 3 plus 5, which is 8. So our answer is going to be x to the power of 8. And remember, we keep the same base. We don't change the base. Just add the exponents. So for number 2, in the same way as we did in number 1, we're multiplying 4 to the power of 4 squared times 4 to the power of 8. So again, we're going to add up these exponents. We're going to add up 2 plus 8. And we're going to leave our base 4. So we're going to have 4 to the power of 10, because 2 plus 8 is 10. Number 3 is asking us to divide x to the power of 6 divided by x squared. So when we're dividing numbers with exponents, we want to subtract these exponents. So we're going to say 6 minus 2, which is 4. So our answer is going to be x to the power of 4. Number 4. Whenever we have a number that is raised to the power of 0, our answer is always going to be 1. So 25 to the power of 0 is going to give us 1. Okay. So it could be like 100 to the power of 0. No matter what number it is to the power of 0, we're going to get an answer of 1. Number 5. We have 3 to the power of negative 2. So in this example, whenever we have a negative exponent, as you guys remember, we are going to make it into a fraction. So we're going to put our numerator as 1 and put 3 squared, so we're just making this exponent positive, into our denominator. Okay, so our answer would be 1 over 3 squared. Okay, for number 6, so we have 4n squared times 6n to the power of 5. So when we have when we're multiplying numbers like this, we want to first multiply these numbers in front of our variable. So 4 times 6, which is going to give us 24. And then again, we want to add these exponents like we did in these two examples. We want to add up our exponents. So we would have 2 plus 5, which is going to give us 7. So we would have, and if it helps you to circle these to remember that you're combining these terms, and then n squared times n to the power of 5. So our answer is going to be 24n to the power of 7. Okay. Number 7, moving on. So we have x cubed to the power of 4, raised to the power of 4. So when we have a situation like this, where we have a number with an exponent being raised to another power, we actually multiply these two exponents together. So our answer is going to be, we're going to multiply 3 times 4, which is 12. So our answer is going to be x to the power of 12. Okay, moving on to scientific notation. So as you remember with scientific notation, we're taking this really, really big number, and we're asking you to write it into scientific notation. So we want to move this decimal until the number is between 1 and 10. So to do that, we're going to count the number of places that we need to shift. So we're going to start at the end, and we're going to count over 1, 2, 3, 4, 5, 6, 7, 8. So I have to move my decimal point 8 places so that this number is between 1 and 10, because 1.2 is bigger than 1, but less than 10. So when you look at a number that you're trying to turn into scientific notation, ask yourself, what do I have to do to make this number between 1 and 10? So again, our number is going to be 1.2 times 10 to the power of 8, because we had to move our decimal point 8 places to make this number between 1 and 10. Okay, next one. So in this case, we have a really small number that we're trying to turn into scientific notation. So the same idea applies. We're going to ask ourselves, how many times do I need to move this decimal point so that my number is between 1 and 10? So I can count over 1, 2, 3, 4. I had to move my number 4 spaces. But if you remember, when we have a really small number as opposed to a really big number, our decimal is actually, our exponent is going to be negative. So when we have a negative exponent in scientific notation, that tells us that our number is really small. Again, our number was 1.2, right? Because that's where we had to move our decimal point, so it was bigger than 1 and less than 10. So 1.2 times 10 to the power of negative 4, because I moved it over 4 spaces. Okay, moving on. So now we're working on multiplying numbers in scientific notation. So, and again, this is all review, so hopefully we remember, but our first step is going to be to multiply the 4 and the 2. So I'm going to say 4 times 2, which is going to give me 8. And then just like we did in the last examples, we're adding up our exponents, because this is telling us to multiply these numbers. So we have to add the exponents. So 5 plus 3 is 8. So I'm going to write down again, we're multiplying 4 and 2, adding up these exponents. So I have 4 times 2 is 8, and then 5 plus 3 is 8. And notice I bring down my base number of 10. That does not change when we're multiplying numbers in scientific notation. Next one, so it's asking me to multiply these together. So again, I'm going to draw my circles to help me visualize what I'm doing. So I'm multiplying 1.5 times 2, and then I'm going to add up these exponents. So I have negative 3 plus a negative 4. So 1.5 times 2 is going to give me 3, and then negative 3 plus a negative 4 is going to give me a negative 7. And notice again, I cut my base. I didn't change my base of 10. Okay, if I'm moving too fast, remember you can pause or rewind if you need to. So next example, dividing numbers in scientific notation. So again, I'm going to want to divide 8 and 2, just like up here we multiplied them. We're going to divide these numbers, and then we're going to, again, subtract our exponents. When we divide numbers with exponents, we want to subtract those exponents. So 8 divided by 2 is 4, and then 6 minus 2 is also 4. So I'm going to bring down my base number of 10, and then write my new exponent.
The final thing we're going to look at today is rational and irrational numbers. So please turn your guided notes over to the back side, and your header will say rational and irrational numbers. We have the definition written on your paper. Rational numbers can be written as fractions. This includes repeating and terminating decimals. Where it says examples on your paper, I want you to copy these examples down. 4 is a rational number, 0, negative 6, 1.58, negative 1/5, 6.66, remember the line over says it's going on forever, and even square root of 81. Notice that most of the numbers we would ever think of are rational numbers. The most common mistake, we think if it's negative, maybe it's irrational, maybe a fraction is irrational. Almost every number that you've seen is rational. All these numbers can be written as fractions. 4 I can make into 4 over 1. 0 I could make 0 over 1. I could put this number over 1. 1.58 I could make 1 and 58 over 100. You don't have to write this down, but we just want you to understand that these are fractions. This is a fraction. Negative numbers are still fractions. And remember, we talked about a way that we could make these repeating decimals into fractions. Remember that rule of putting it over 9, or we put this over 99? That can also be written as a fraction. A square root of 81. 81, remember, is a perfect square number. The square root of 81 is 9. Okay? So that is also rational. So what numbers are irrational? Well, irrational numbers are those strange numbers that go on forever. It has to be a number that goes on forever, and it doesn't just repeat the same number over and over. The example we've talked most about is pi, so please write that down. Remember, that goes on forever, never stops, doesn't have a pattern. And then most square roots are also irrational. Any square root that's not a perfect square, so 81, square root of 81 is 9, but notice square root of 2. There's not a number you can come up with. 2 is not a perfect square. It's not one number times itself. So that is irrational. Square root of 57 is also irrational. Even something like square root of 10, even though that's needs to be an even number, that's also irrational. Okay? Because 10, it's not a number times itself to give you 10. So most square roots are irrational, and numbers like pi. Final thing we're going to look at is how to approximate square roots. Okay, so again, remember that most square roots are irrational numbers. Square root of 51 is an example of that. It's irrational. It's not a perfect square number. You can't find a number times itself to give you 51. So this number is going to go on and on forever. We can't find this number exactly, but what we can do is we can estimate where this number is going to fall. We can know around what number it goes in. We can order it, we can put it on a number line. The way that we're going to approximate this number is we're going to find two numbers on both sides of this 51 that are perfect square numbers. Okay? So what I'm going to do is I'm going to find a number below 51 that's a perfect square, and a number above 51 that's also a perfect square. 49 is a perfect square. That's 7 times 7, and it's very close to 51. 64 is also a perfect square number. 8 times 8. That's just a little bit above 51. So we've put square root of 51 in between these two square roots. Next thing I'm going to do is I find the square root of 49. Since 49 is 7 times 7, that means square root of 49 is 7. 64 is 8 times 8, so the square root of 64 is 8. Now since square root of 51 is in between these two numbers, I know that square root of 51 is in between 7 and 8. Okay? I know that square root of 51 goes somewhere in here. Now I could guess that it's 7.5, but I can get a little bit more accurate because we can determine which of these two numbers is square root of 51 closer to. So let's think, is it going to fall here or here? Well, square root of 51, 51, is it closer to 49 or 64? Let's think about that. Did you say 49? It is closer to 49, right? 51 is much closer to 49 than to 64. So, we know it's going to fall into this region here, right? It's going to be closer to the 7 than to the 8, because 51 is closer to this 49. So we're going to say that square root of 51 is in between 7 and 7.5.